Today we see about multiple sequence alignment. Multiple sequence alignment is generally the alignment of three or more biological sequences, that is protein or nucleic acid of similar length. From the output, common can be inferred and the evolutionary relationship between the sequences studied. So from this multiple sequence, we can be able to understand the homologous sequences that between the between the different organisms, and also we know the evolutionary relationship between the different organisms. By contrast, pairwise sequence alignment tools are used to identify regions of similarity that may indicate functional, structural, and or evolutionary relationship between the two biological sequences. In pairwise sequence alignment, we have to take two sequences. Between the sequences, we can find out the functional, structural, or evolutionary relationship between the two sequences, or any two sequences. We have to use pairwise sequence. Use the tool is classed. But in multiple sequence alignment, we use the tool is cluster. Cluster is a series of widely used computer program used in bioinformatics for multiple sequence alignment. There are different type of cluster is that there cluster W, cluster omega. Cluster omega is a new multiple sequence alignment program that uses seeded guided trees and the custom profile techniques to generate alignments between three or more sequences. For the alignment of two sequences, please instead of use our pairwise sequence alignment tools. If you have to choose, we have to find out any sequences similarity between two sequences. We have to use only class tool. If you want to find out the similarity or evolution relationship between more than two sequences, we have to use the tool cluster. Next is the importance of MSA means multiple sequence alignment. Multiple sequence alignment has assumed a key role in comparative structure and function analysis of biological sequences. It often leads to fundamental biological insight into the sequence structure function relationship of nucleotide or protein sequence families. So likewise, class here also we have to do protein sequence multiple sequences or nucleotide multiple sequences. That's all about the theory part of multiple sequence alignment. Next we see about the practical section. So first we have to open the global search, then we have to type class star W, and then we have to click enter. There will be different class star. We have to click search. We will sort the multiple, the different type of list will be there. In this, we have to choose multiple sequence alignment class star W. It is given by the genome net. So you have to click this. So this is the home page of class star W. Already in just like a blast, you have to here choose someone, that is if the outer format is class star, flip, anything, or faster format. We have to choose. Now we have to choose the class star, and also alignment is fast or approximate or slow or accurate. Then we have to choose which sequence we have to compare, protein or DNA. So now we compare DNA sequences. Already I have retrieved 5 sequences in the notepad of collagen. So these are the 5 different organisms sequences in notepad. So I have to select all, and then it is copy. Then I paste it in this box, and then I have to click execute multiple alignment. We have to wait for the result. Then we go to select the fast tree, execute. Wait for a few minutes. So before that, in this, we have to paste how many sequences are also seen here. 5 sequences. How many base pairs each sequence having? Most probably we have to choose similar length. That will give a more accurate result. I have to take one is where 9, 10. Then there's a different length of sequence also take care. So here it is multiple. It will take only mostly four groups for the alignment. Then sequence alignment between the each sequence. Okay. So these are the first page. Next, we have to click the tree size. So here the results will be there. So this is the phylogenetic tree. Already we studied in the theory one because it's based on the neighbor joining method. This is branch length. How much of this is the two sequences. The ID will be given. We have to we know the ID and then we are find out the organisms also. Here, what is the relationship between these two organisms? And then next one, then third one, fourth one. So we are find out which organism is close to this ID. Then this is the one close one. They are a very close relationship between them. And then which one is far relationship means for this ID, this is the far relationship organisms. So what is the distance? What is the evolution led distance between them is noted in this position. This two of the distance is that this organism have a distance evolution distance between this organism is 0.22 3196. And these three have a distance between these two is this one. Okay. So we have to take without branch length. Then the length will be removed. Uh, Branch labels also removed. Then without ticks means this mark will be clean. Then without leaf labels for the sequence and leave it. But we need this all this, so we have to remove the tick. So, okay. So this is the final result. We can save it by using this images of printout. Okay, that's all about the multiple sequence alignment. You can also change here we can able to change lid tools or then pasta everything. Likewise, now we have to choose the sequences for nucleotide. So we have to click this DNA. Now, if you have protein, then you have to choose a protein and then paste your protein sequences. Okay, that's all about the multiple sequence alignment.